This will be for the con assignment probability with discrete random variables. It says Hugo plans to buy packs of baseball cards until he gets the card of his favorite player, but he only has enough money to buy at most 4 packs. Suppose that each pack has probability 0.2 of containing the card Hugo is hoping for. Let the random variable x be the number of packs Hugo buys. Here's the probability distribution. Find the indicated probability. So they're asking us the probability that x is greater than or equal to 2. So there's actually 2 ways you can do this. Okay? If x is greater than or equal to 2, it can be 2, 3, or 4. So in other words, you can add the probability that it's 2 plus the probability that it's 3 plus the probability that it's 4. However, there's only 4 options here. So all of the options, probability-wise, have to add up to 100%. And of course, 100% in terms of a decimal is just 1. So x is greater than or equal to 2 means it can't be just 1. So all we have to do is subtract this from the number 1. All right, so the probability is just 1 minus 0.2. And of course, that's going to be 0.8. If you want to double check, you can just add these 3, but it's the same thing. So click inside the box, and you can type 0 or just type 0.8. Okay, so same write-up here, same write-up, same table. What is the probability that Hugo buys fewer than 3 packs of cards? All right, so it has to be less than 3. All right, so it's either going to be 1 or 2, and we just add 0.2 plus 0.16. That's going to be 0.36. Click inside the box and type 0.36. A data scientist tracked how many cups of coffee she drank every day at work over the course of the year. She used the data to build a probability distribution where the random variable C represents the number of cups of coffee she drank on a given day. Here's the distribution, partially completed. Find the missing probability in the table. All right. Like we said before, these are all of the possibilities, either 0, 1, 2, or 3 or more cups of coffee per day. All right, these have to add to 1. All right, so adding these all together, they have to equal 1. So we have 0.1 plus 0.85, that's 0.95, plus 0.05 equals 1. So in other words, we have the question mark, and if we take these together, question mark plus 1 equals 1. Okay, and if you just subtract 1 from both sides, the question mark equals 0. So there's no chance that she only has 0 cups of coffee. In other words, she's definitely going to have coffee. So click inside the box and just type 0. All right, so in case you didn't understand what I did, again, these have to add up to 1. All 4 of them have to add to 1. So I just subtract these 3 from the number 1, and that will give me the question mark. But when you subtract these 3 from 1, it will just give you 0. All right, Cora is playing a game that involves flipping 3 coins. H is the number that lands on heads, and here's the distribution for the probability of heads. They want to know the probability that H is greater than or equal to 2. All right, so it could be 2 or it could be 3. So all you have to do is add this plus this, and that is going to equal 0.5. So click inside the box and just type 0.5. And the alternative would be to subtract these two from 1, and you'll get the same thing. All right, the first digit of data entries in most real-world data sets are not uniform. The most common first digit is 1, followed by 2, and so on, with 9 being the least common. That's called Benford's law. All right, so they gave us the probability distribution here. All right, this is almost like two separate tables right here. All right, this is if it begins with a 1. This is if it begins with a 2, and so on. And they want to know the probability that a randomly selected digit has the first digit less than 4. All right. So that can be either 1, 2, or 3. If it has to be less than 4. So all you have to do is add these 3 probabilities. So I'll do that on the calculator, and I get 0.602. So just click inside the box and type 0.602.